In this episode, we start by grounding data security in a simple truth that new learners often miss. Most security controls become far more effective when the system understands what the data is and how sensitive it is. If every file, record, and message is treated the same, then access rules get blunt, monitoring gets noisy, and people end up either overprotecting everything or underprotecting the things that truly matter. Data classification is the practice of sorting information into categories based on how harmful it would be if it were exposed, changed, or lost. Once you have categories, you can design controls that scale because the rules can follow the category instead of being reinvented for every single document or database table. Labeling and tagging are the practical mechanisms that let the category travel with the data, so the controls can recognize it wherever it goes. When you design these elements well, you get security that feels intentional and consistent instead of random and reactive. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A classification model is the set of categories you use and the logic behind them. And the most important beginner lesson is that the model should reflect business impact, not technical complexity. A highly sensitive spreadsheet can be more important than a complicated application log, and the classification should capture that difference in a way people can understand. Many organizations choose a small number of levels because too many categories create confusion and disagreements. The categories are usually ordered from least sensitive to most sensitive, with a clear explanation of what each category means in practical terms. The model should also define what kinds of data typically belong in each category, because examples reduce guesswork and keep decisions consistent. When the model is designed around impact and clarity, it becomes a shared language that makes later control decisions easier and less emotional. If the model is vague, people will classify based on personal fear or convenience, and the entire strategy starts drifting immediately. A useful way to connect classification to security outcomes is to remember that data can be harmed in different ways, and your model should anticipate those differences. Some data is primarily sensitive because of confidentiality, meaning exposure would cause harm, such as customer identifiers or internal financial reports. Some data is sensitive because of integrity, meaning unauthorized changes could cause harm, such as payroll records, system configurations, or transaction histories. Some data is sensitive because of availability, meaning losing access to it would disrupt operations, such as key operational databases or critical design documents needed to keep systems running. Beginners sometimes treat classification as only about secrecy, but that leaves gaps where integrity and availability risks are ignored until an incident happens. A strong model acknowledges that sensitivity can come from different kinds of harm, and it gives you room to design controls that match the real risk. When classification includes these dimensions, it also helps explain why a piece of data might need strict change control, even if it is not particularly secret. Once you have categories, you need criteria that help people classify consistently, and the criteria should be simple enough that normal employees can apply them without a meeting. Criteria often include legal or contractual obligations, the expected audience for the information, and the potential damage if the information is shared or altered. For example, data intended for the public should not require the same controls as data intended only for internal teams, and data intended only for a small group should have stronger access restrictions than broadly shared internal information. A common misunderstanding is to classify based on who created the data rather than what the data contains, which leads to incorrect assumptions like treating every document from a certain department as sensitive. Another misunderstanding is to classify based on how hard the data is to produce, which mixes up business value with sensitivity. The best criteria focus on consequences, because consequences are what security is trying to manage. Clear criteria also make it easier to automate parts of classification later, because automation needs rules that can be evaluated reliably. Labeling is the human-friendly representation of classification, and it matters because people need visible cues to make good decisions. A label is what someone sees when they open a document, send an email, or view a record in an application, and it should communicate what handling rules apply. If a label is invisible or buried, people will forget it exists, and then the label cannot influence behavior. Labels can also help reduce accidental sharing, because a visible reminder of sensitivity often causes someone to pause before sending data to the wrong place. This is not about shaming users. It is about designing a gentle friction that prevents the most common mistakes. Labels should be consistent across systems so users do not have to learn a different language for each tool. When labeling is done well, it becomes part of everyday awareness, like a road sign that quietly guides behavior without requiring constant training. Tagging is closely related, but it is more about machine-readable attributes that systems can use to enforce controls automatically. A tag might represent a classification level, a data type, a business owner, a retention requirement, or a regulatory category, and tags are especially powerful because they can travel with data into storage, backups, analytics pipelines, and monitoring systems. Beginners often assume tagging is just administrative decoration, but tagging is what lets a system make decisions at scale, such as blocking certain data from being copied to unapproved locations or requiring extra approval for exports. Tagging also helps security teams focus monitoring and alerting because tags can indicate which data access events deserve stronger scrutiny. When you design tags, you want them to be stable and meaningful, not a constantly changing set of labels that nobody trusts. Too many tags can be as damaging as too many classification levels because complexity creates inconsistency. A small, well-designed tag set can drive surprisingly strong enforcement when it is applied broadly and maintained carefully. One of the most important design choices is deciding which parts of classification are manual, which are automated, and how conflicts are resolved. Manual classification is valuable because humans understand context, but it can be inconsistent, especially under time pressure. Automated classification is valuable because it scales and applies consistently, but it can misclassify if the rules are too simple or if the content is ambiguous. The best designs often combine the two, where automation makes a first pass and humans confirm or adjust when needed. This is especially helpful for beginners because it reduces cognitive load while still keeping accountability. You also need a rule for what happens when classification is uncertain, because uncertainty is common and the system must behave predictably. A sensible default is to treat uncertain cases more cautiously until someone clarifies, but that caution must be balanced against usability so people do not bypass the system. Conflict resolution rules, such as letting the highest sensitivity tag win, prevent dangerous downgrades and keep enforcement consistent. Classification, labeling, and tagging become truly valuable when they connect directly to access control decisions, because access is how most data breaches happen. If sensitive data is tagged, your access system can enforce least privilege more precisely, granting access only to the roles that need it. It can also enforce separation between general users and administrators, and it can require stronger checks for particularly sensitive actions like bulk export. Beginners sometimes think access control is only about logging in, but authorization is the bigger story because it determines what you can do after you are authenticated. Data security controls should ensure that access decisions are based on the user's identity and the data's sensitivity, not on vague assumptions like being on the internal network. Tag-driven access can also support time-based or context-based restrictions, such as limiting sensitive access from unmanaged devices. The key point is that classification should not live on a slide deck. It should become an input to real enforcement points. When it does, data protection becomes more consistent and less dependent on perfect human judgment. Data protection also includes how data is stored and transmitted, and classification helps you decide where to apply stronger safeguards. More sensitive data may require stronger encryption controls, stricter key management, and tighter separation in storage locations. Even if you do not dive into technical details, you can understand the design intent. If a laptop is stolen or a storage system is misconfigured, encryption reduces the chance that exposure becomes a full breach. Classification also helps define where sensitive data is allowed to exist, which is a surprisingly important control. For example, you might decide that highly sensitive data must stay in approved repositories and must not be copied into personal notes or informal collaboration spaces. That kind of rule is hard to enforce without tags and labels, because the system cannot tell what the data is. When classification guides storage and transfer controls, you reduce data sprawl, which is one of the biggest enemies of security because sprawl creates countless small leak paths. Monitoring and detection improve dramatically when they are informed by classification, because the same event can mean very different things depending on the data involved. A large download of public information might be routine, while a large download of sensitive information might be a serious incident indicator. Without tags, monitoring systems often generate alerts based on volume alone, which produces noise and misses the real story. With tags, you can tune detection rules to focus on high-value data, unusual access patterns, and unexpected destinations. This also supports investigations, because responders can quickly understand what kind of data may be involved, which helps prioritize containment steps. Beginners should notice the feedback loop here. Classification helps monitoring, and monitoring helps validate classification by revealing how data is actually being used. If sensitive data is accessed frequently by a broad set of people, that may indicate overclassification, poor access design, or an unexpected business workflow that needs to be addressed. Detection by design becomes far more actionable when the system knows what is sensitive and can treat it differently. Data loss prevention, DLP, is one of the most common places where classification and tagging pay off, because DLP depends on identifying sensitive data and applying handling rules. DLP can help prevent accidental sharing by blocking certain data from being pasted into unapproved places, uploaded to unapproved services, or emailed to external recipients. It can also help detect risky behavior, such as repeated attempts to move sensitive files or unusual patterns of copying and downloading. Without classification, DLP often relies on pattern matching alone, which can miss sensitive information that does not fit neat patterns and can flag harmless text that coincidentally looks sensitive. When tags are present, DLP can be more precise, because it can apply strict controls only when the data is tagged as sensitive. This reduces friction for normal work while increasing protection where it truly matters. A beginner misunderstanding is to think DLP is a magic shield that stops all leaks, but it is more accurate to think of it as a policy enforcement system that becomes powerful when it has good signals, and tags are one of the best signals you can provide. A classification strategy must also address the data lifecycle, because data does not stay in one place or one state forever. Data is created, edited, shared, stored, archived, and eventually deleted, and each stage can introduce different risks. For example, data might start as internal and become public later, or data might start as sensitive and become less sensitive after a certain time, such as when a project is completed and published. If classification cannot change when reality changes, you end up with labels that stop matching the truth, which erodes trust and compliance. Lifecycle design includes retention rules, meaning how long data should be kept, and deletion rules, meaning how data should be removed when it is no longer needed. It also includes backup considerations, because sensitive data can live in backups long after it is deleted from primary storage. Tags can help enforce retention and deletion consistently, but only if ownership and governance are clear. When lifecycle is ignored, sensitive data lingers, and lingering data is risk that keeps growing quietly. Governance is the part that keeps classification from becoming a one-time project that slowly rots. Someone must own the classification model, define how new categories or tags are introduced, and manage exceptions without letting exceptions become the default. Ownership should also include training and communication, because users need to understand what labels mean and how to apply them. Auditing helps too, because you can sample data and check whether classification matches policy and whether controls are working as intended. Beginners sometimes imagine governance as bureaucracy, but good governance is what makes the system predictable, and predictability is what makes enforcement reliable. Governance also includes handling disagreements, because not everyone will agree on sensitivity levels, especially when business teams fear exposure and security teams fear sprawl. Clear criteria, consistent examples, and a simple escalation path reduce those conflicts. When governance works, the model stays stable, the tags stay meaningful, and security controls stay aligned with real business needs. It is also important to design classification so it works in messy, real environments where legacy systems exist and perfect automation is not possible. Some systems may not support modern tagging. Some repositories may not display labels cleanly, and some workflows may involve data moving through places you cannot fully control. In those cases, the goal is not to abandon classification, but to design pragmatic bridges. You might use gateways that add tags when data enters a controlled repository, or you might require sensitive data to be stored in systems that support labeling while limiting sensitive data in systems that do not. You might also use compensating controls like tighter access restrictions and stronger monitoring around legacy data stores. Beginners should recognize that the perfect model is less useful than a workable model that is applied consistently. Real security progress often looks like improving coverage steadily rather than achieving instant perfection. When classification is designed with legacy reality in mind, it becomes a tool for modernization, guiding where you invest effort to get the biggest risk reduction. A subtle but critical risk is overclassification and underclassification, because both can break your strategy in different ways. Overclassification happens when too much is labeled sensitive, which creates friction, encourages workarounds, and makes alerts noisy because everything looks important. Underclassification happens when sensitive data is labeled too lightly, which creates silent exposure because controls are not triggered. The best defense against both is clarity and feedback. Clear criteria and examples reduce misclassification, and monitoring and auditing reveal where classification does not match actual usage and risk. It also helps to design an easy, safe process for reclassification, so users do not feel stuck with a label that no longer fits. Beginners sometimes think the safest answer is to label everything as the highest level, but that usually creates a culture where people ignore labels entirely. A model that people trust and can follow is safer than a model that looks strict but is routinely bypassed. As we close, the central idea is that data security controls become far more effective when the system can distinguish between different kinds of information and apply different rules accordingly. A well-designed classification model gives you a small, clear set of categories based on impact, not fear, and it includes criteria that guide consistent decisions. Labeling makes sensitivity visible to humans, so everyday choices become safer, while tagging makes sensitivity readable to systems so enforcement can scale. When classification feeds access control, storage rules, monitoring, and DLP, you get a coherent strategy where controls reinforce each other and data sprawl is reduced. Lifecycle thinking ensures labels and tags remain accurate as data ages, moves, and is eventually deleted, and governance keeps the whole system from drifting into chaos. If you can design classification, labeling, and tagging as part of architecture rather than as administrative chores, you will be able to build data security that stays strong under real-world pressure and changes, which is exactly the mindset SecurityX expects you to develop.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.